session, and I think if there's something you've picked from the first session in the pairing game is the economics that actually plays out when it comes to interconnection. So in this second session, the question you should ask yourself is, what's in it for you? And you saw people trying to, whenever they were building into the different blocks, the question is how they would actually get to peer with somebody and benefit more. So in this session, we're going to look at what's in it for you and how you actually can build your network so that you can actually benefit more from interconnection. So first up, we have Martin Levy from Hurricane Electric, and he's going to give a presentation on the value of flow data for peering decisions. So how can you actually use flows to make your peering decisions? So Martin, please welcome.
Thank you. I'm going to walk in front of the screen. I just feel easier doing this. So my name is Martin Levy, and I normally, as some people that know me, end up talking about IPv6. And I'm not going to do that today. The good news is I don't need to. But more importantly, I'm going to talk to the subject of measuring traffic. Measuring traffic as it relates to internet peering, because it's a little subtle. It's not as obvious as measuring traffic around a network in general and doing capacity management. So when talking about this, what I want to do is I want to give you examples of data collection as it relates to internet peering. I'm not going to go through all the fine details of how to implement that. That's really more for system administrators, network administrators, geeks, etc. But what I am going to do is sort of talk as if you are either a peering manager or you're a capacity manager, somebody who is responsible for profit and loss inside a company, inside a network. Because, to be honest, that's actually where this all comes down from. As Bill showed in his game, money is a fundamental driver in a lot of the reasons why we build peering and why we expand networks. Now, a couple of things I'm going to explain about this talk. First of all, it's all real data, live data collected in the last 24 hours. So it's nice and fresh. But it's all been obfuscated. There will be no network names. There will be no AS numbers. There will be no IP addresses. And there's a very good reason for that. And that is because a majority, if not all, peering agreements have a clause in there to do with non-disclosure. So in fact, actually, let's say I peer with somebody else that's inside this room. And I do. I peer with various different networks that have representatives here. The agreement states that I can't publish the specific information about that peering, how much traffic, what bits, etc. So everything here is obfuscated for that reason. What I'm not going to cover, because it's going to get covered by other people, is what type of software, and as I said before, the actual nitty-gritty of doing configuration. That will be handled by somebody else. So let's ask the simple question. We keep using this word flow. I was introduced that I'm going to talk about flow as it relates to peering, but what is it? And it's actually one of those near unfortunate sort of circular definitions, but it's a way of exporting flows. So we have to now really know what a flow is. And a flow is the connection that gets created when you go to a web browser, for example, and look at a page, and maybe download an HTML, and download 100 images, and maybe download a bunch of other stuff, or an email that gets sent out. That single TCP connection is called a flow. We start, we send a bunch of data, we stop. That's the flow. Not every bit, but the collection of those bits. Now, why are flows more interesting than just data? And we'll see that in a moment. But it will become very obvious, and you'll see this repeated as I go through this, is that instead of just counting the bits, it's counting where the bits went. And for peering operators, for people running networks, that's very important. Capacity planning says, I have a piece of fiber. It is configured with a particular speed. Is it full or is it not full? That's capacity planning. In the peering world, I have a port on a peering exchange, and I am talking to 1, 2, 10, 100, if I'm an AMSIX, nearly 500 peers. Who's using the most amount of bandwidth? Who's using the least? Who suddenly changed? That's what flows are about. Now, it turns out that there's a bunch of different flow protocols, because anything good gets created many times over. Again, I'm not going to get onto the geeky side of this and talk about the difference, but I will hit a couple of points as I talk about this. First of all, it's about sampling data. So if you are paranoid about knowing every single solitary bit and knowing everything that's going on, flows are not for you. But if you want the big picture, if you want to understand where traffic is flowing in the sort of take a 10,000-foot view, then flows are great because you sample. So I have two graphs here, and I'm going to show you the difference. This is a graph that is from a connection to an internet exchange. The scale here is whatever it is. It goes up to about 2, 3, 4 gigs here. And it shows that bandwidth has gone up and down. Green is one direction, blue is the other. That is a bandwidth graph, and it's probably pretty familiar to what you may see on your existing networks. Now, if I look at this graph, I can tell you that something happened, and I can tell you that it went up and down every day, and that's really all I can tell you. I can't tell you where the bits and who they were, and who the players were. Was it my customer in city A, or city B, or city C that caused this change? Did I turn up a new peer that made the internet exchange move more traffic, which is presumably a good thing? I don't know. But here's an example of exactly the same data, but in this case I picked a flow that shows and separates it, which is one of the things you can do in flows, between V6 data and V4 data. So all of a sudden at this point, obviously the change was something in the V4 space. Now what was it? Well, we'll hold off on that for the moment. We'll use some different examples. But instead of it just being one number here that's recorded for traffic, what we have here is the ability to go in and rip apart the traffic and know a little bit more about it. In this case, I just picked a graph off of our system that separated V4 and V6. Did that with flows. Did that in a way that gave us the ability to then delve deeper into this. But again, I'm going to give you examples of this. So let's talk about how this is all done. It's done in a very simple manner. On the routers, or routers, depending on how you say it, you're going to collect information. And you're going to collect information either for every single packet or a sample of packets. Now, when you start using gigabits and tens of gigabits and maybe hundreds of gigabits worth of traffic, it turns out sampling is very important because you just can't count that quickly. And more importantly, you can't upload, which you'll see in a moment, to a collector. So in the flows world, we grab every N packets and we look at what they do. We look at information associated with it, and we send it to a collector. But what does the collector do? Well, very similar to the way that traffic is saved today, in the collector, we do something slightly different. We actually interpret the data a little bit more. We obviously store it for as much time as possible within the bounds of either the system, the expenditure on the system, or maybe there's a legal requirement. You may only be allowed to keep certain data for a month, or 2 months, or 3 months. But the bottom line is you provide a user interface to actually interpret that data. And the key point about flow data is you may not really know what you're meant to be looking for. So storing it and coming back later and interpreting it is very valuable. In the traffic world, traffic is traffic. What simply happens is that packets have a certain bandwidth, on a certain pipe, you record it, and you're done. There's nothing much you can do with it. Okay, so what does it look like in a picture? Pretty obvious in a way. We have a network of some variety. We have a bunch of boxes, routers on that network, and we will then send the data over maybe the same network into the collector. And we send, of course, these samples into the collectors. We do it every minute, every 10 seconds, every 5 minutes. This is very much in the configuration and the size of the network. Very large networks have to send more information. They may in fact have multiple collectors because they may have one in one geography and one in another. The collector's process obviously is not to lose that information and then to interpret it. So what I want to do is I want to run through both the type of information that is collected and why, if you are managing a network, you should be going to your network engineers and saying, do we collect flow data? And if so, how do I get access to it? Because without that, I have a blind network. So let's look at the flow traffic. I'm sorry that this red is a very bad choice here. But basically, there are, in the flow information, lots of techno-weedy stuff. Again, I'm trying not to be technical about this. But the bottom line is we have this information that's blindingly useful to the peering world. What we have is we have AS information here. We have the origin and the or the peer information on top of the IP address. In the traffic world, we have none of this information. So instantly, we have a view into the source and the destination. If you're using a laptop or an iPad and connected to the Wi-Fi here, you have an IP address. In fact, you're somewhat unique on the internet. And flows can come in and say, maybe I want to look at the traffic of a particular IP. In reality, because of everything being sampled, that actually doesn't work as well as you think, unless you have a very large amount of traffic. So the AS becomes more interesting. We live in a particular AS number here inside this room as part of the network that supplies connectivity for the conference. It then connects through peering and through transit to the rest of the world. And because of that, flow data can use that AS number and make some interpretation of it. So again, packets are sent with lots of useful information. There's also TCP and UDP source ports, there's protocol types, there's type of service. You can do a lot more with flows than what I'm going to talk about for peering managers. But what isn't in here is the actual data in the packet. The fact that a website contains some useful information is not what flows is about. It doesn't want to store that information. All it cares about is communication from one player to another player, and hence the information here is nothing more than the networking addressing.
Larger packets and flow, that's not the data?
No, that's the, sorry. Well, okay, I didn't explain this part, but Bill asked, and I'll go into a little bit more. So packets in the flow gives you actually a count of the amount of traffic. So what this provides you is a measure of bandwidth, but a measure of bandwidth as it relates to the particular AS and IP addresses, as opposed to the physical port. So that's actually what I was going to get to here. So flows provide you ASM-based information, a mapping of source and destination. And you can start looking for very large sources or destinations if that's important. You obviously get the ability in the collector then to map that to something that is humanly useful, the number of bits per second. Sometimes packets per second is useful if you're looking for attack traffic. But we're going to stick to just basic bandwidth graphs with everything I've got here. And you also have this additional data. I showed already a graph that started to separate V4 and V6, because that's actually quite useful to know in the days as we have been progressing in deploying V6. Now we can also look at source address and destination address and source port and destination port. Now that gives us the ability to separate traffic as HTTP traffic for web browsing, or secure web browsing, or email, or DNS, or other traffic. Again, you can do a lot more with this, but I'm going to focus purely on the peering role, not so much on other aspects of networks. So I have a bunch of graphs that really, it's the easiest way to explain some of the usefulness of why you want flow data. Remember in the network diagram, the network graphs that we saw originally, all we saw was a big green or blue graph showing how much traffic was on a port, on an exchange port. This is an example of a graph where the exchange is now pulled apart and it shows which peer has which traffic. So this, again, as I explained earlier, these are all real graphs. So here we have traffic from multiple different ASs. They're colored differently. And those graphs add up and look like the graph that we expect to see day in and day out on our network. However, we're now delving into it, and we can see there's a pretty big peer at this internet exchange. And there's a sort of smaller one and a smaller one and another one here. And this may be just the rest of the traffic that is yet to be, any other AS. This is probably off of an exchange, actually I don't remember which one I captured. Probably off an exchange in Europe, probably, as I said, one with a very major peer. And the traffic would sum up to the total amount of traffic on the exchange, but the ability to see into it and see which peer becomes very important. For example, you may realize that one of these peers that's moving 2 or 3 gigs of traffic may exist in another city, and it may be interesting to spread the traffic around because of the geography of their network and the peering network, our network in this case. There are lots of things that can be interpreted very quickly from just breaking down in a vertical sense the traffic. The second example I have is a different view. This is one ISP peering with us in, I think, 3 or 4 locations. I think they peer in 4 locations, one of them is not used. And what you see on this graph is the sum of all their traffic over these multiple exchanges on the same graph. So this may be from one router, it is, in one city. This is from a different router in a different city on a different exchange. This is from a different router in a third city on a different exchange. But out of each one, they're not the traffic graphs of the internet exchange, they're purely that one ISP. By adding them together, I get an overall view of what the traffic is like between this provider. Now notice the Saturday and Sunday, so this is obviously something that just seems to disappear over the weekend, but comes back with a vengeance on Monday morning. It's an interesting graph, but without flows, I could never interpret how that ISP, how that other network was operating against our network. Notice that we can tell that this particular peer location is contributing a fairly small amount between our 2 networks. These other 2 seem to be about equal. Maybe the one in the middle is the biggest. But the reality is that only with flow data can I actually start interpreting and seeing this. This is the second version of that same graph, just again, the user interface just flipped and changed. And now I just overlay each graph. There is actually a 4th location with a tiny amount of data there. So now I can see the individual graph from each one. And then, by the way, interesting about this, this actually is a hosting entity. Again, I'm not going to tell you who because I really can't. But you can tell that something disappears around lunchtime and then kicks back in again. And the timeline here seems to be pretty US-centric. So one of the things I know about this peer is that this traffic is presumably restricted to the United States. There's very little traffic going to anywhere else in the world. Otherwise, I would see different peaks for different daytime or night times around the world. Okay. Now we can go do something completely different. We're peering coordinators. We not only look at peering points, but we have to look at the traffic that we're sending to the peering points. So now we're going to do a complete 180 degree, and we're going to now look at the customer. And the customer is sending us traffic, or receiving traffic, depending upon the type of customer. And some of that traffic is going to existing transits, and some of it is going to peering. So by taking this graph, and it took me a while to find a graph that was useful to show, but here's a customer. We know their total bandwidth. We can tell that because we can look at the customer-facing port. Oh, we could look at their invoice, their bill, because we're billing them for traffic at a particular bandwidth level. But as a let's say a product manager for the transit business, or a general manager for the whole business, now the question is, can I use flows to actually delve into that and say, how efficient is my transit and peering? So here you've got the ability to say, hey, it seems like more than 50%, 60% of the traffic is going to peering, and maybe 30% is going to transit. So I can start doing a cost analysis on this particular customer. Now you're not looking at what traffic level. This is the traffic that is peering, and this is the traffic. This is the traffic that is peering, and this is the traffic that is coming from transit. So flows become useful from the opposite point of view, and this is about, again, allowing the value of peering to be seen at the customer level. Got a couple more graphs here. This is now a different customer interpreted to which peer is which. So we obviously have, there's some big peer here, there's a little peer here, and this is considered to be all the rest of the peers. Well, what that means, the rest of the peers is, in a network like ours where we peer with thousands of different networks, that's a lot of very small peers that can add up to a large amount of traffic. But what's interesting is this here shows that there's just one peer that may be moving 2, 3 gigs, maybe peaking at 4 gigs worth of traffic. One peer to one customer. I want to know who that is, and I want to know whether I can engineer it better. But if I just look at traffic graphs, I can't see that. All I would see is some peaking customer going up and down here, whereas now I can actually say I want to do something specifically with that customer. So again, flows become useful on the customer level and as you look at peers. I told you about looking at transits earlier. Here's another one. And in fact, it's probably one of the most appropriate ones. You're paying for transit. You're paying another company. And the goal of peering, amongst many things, besides bringing your network and improving your network and expanding your network, is also to reduce cost. So here's an example of looking at a bunch of transit traffic and saying, hey, I'm peering with a particular network and a different network and a different network. And I know, sorry, I'm not peering. I would want to peer because this traffic is being sent to transit, but because I've actually built a graph up that can look at a particular AS number, I now know the value of going to a peering exchange. I now know that requesting peering from this particular AS will in fact reduce my transit costs. There is real traffic. And in some cases, as peering matures with inside a market, you may have a large operator say to a slightly smaller operator, well, how much traffic are you actually sending me? Without flows, that's near on impossible to know. So again, we can take the data that we're collecting and even after the fact, go back and look at this and interpret it in some useful manner. All right, let's hit a couple more points, really simple. You don't have to be graphical about all flow data. I want to show you this. I've actually taken the liberty of taking one of our ports. So again, live data, I'm showing you real data, but I've obfuscated it enough to be acceptable to show. This is actually a public graph. You can get at this graph. I won't tell you where, but you can get to it. So this is our graph on one of our 10 gig ports in Stockholm, Sweden, on the NetNode exchange. It goes up and down, it's sitting at about 4 gigs at the moment out of 10. There's a few ports there, it swaps around every now and again. But all I can tell you from this graph is that we go up and down, this was grabbed a few hours ago. We go up and down and it's 4 gigs. But who am I peering with? Well, it turns out that our tools internally then give me the ability to turn around on my traffic graphs and instantly look at my inbound and my outbound traffic. And here, again, I'm sorry that I've removed all the ASs and the names, but I have to. Here I turn around and take that 4 gigs worth of peak, although I think we weren't at a peak, we were about 2.4 gigs, so we were down, well, we were down here actually when I did this. And now I can turn around and say, you know, 800 megs of that traffic is going to one AS number. Or coming in from one AS number, going out, coming in. This is in, yes. And, oh, it's a green, yeah, sorry. So this graph is off the Internet Exchange. So in and out is inverted from in and out here. I'm sorry about that. So the green here associates with the blue there. But I can turn around and look at my various peers, and I can say, okay, I know who the big players are. But I'm looking at this instantaneously. I'm not looking at it as a graph. I'm just using this as a tool. For us, this is built into our systems. We can do this for any customer port. We can do it for any peer port. We can do it for any backbone link. We can do it for anything instantaneously. And I can keep clicking, and I can interpret this even further. But the bottom line is, I'm immediately looking at this and saying, you know, I've got a peer here, whoever this is, that is using nearly twice as much of the bandwidth as my next peer. So I can make an instant realization on the usefulness of that particular exchange. So the goal for showing these graphs and this was just to run you through some of the things that you can do with flows. It was for people on the business side of the business to turn around and say, hey, we need this capability. If you don't have it inside your network, for want of a better way of saying it, you're running blind in the peering world. You can make some good assumptions, but you can't exactly know what's going on. So, I mean, really, you can tell I really don't want to touch this subject very much, but being that Arbor is one of the sponsors of the conference, I realized I should do this. There are commercial offerings, one of which is Arbor. There are open source offerings, and XSend will get you part of the way. It needs a lot more work. There are values to open source, there are values to commercial. There are different capabilities. I've just given you just this very, very high level view of this. So in summary, just to sort of repeat the parts I've said and make sure that there's a takeaway for everybody. You know, operating something that collects flows and using this data gives you a view inside your pipes. Now, it is possible, by the way, and I haven't touched this subject, but it is possible for some Internet Exchange operators to actually run flows on their switches if they've got big enough switches with enough capability so that they can give that information. That's up to the Internet Exchange operators. But you need to run a pretty good infrastructure to do that. Being able to judge things by AS number, which is the building block of the peering world, fundamental, absolutely fundamental. This other point is that it gets peering points to come alive. It gets you to understand, delve into what the traffic is, where it's going. You can't run a network when it gets too big, without this type of information. The other thing is it gets you the ability to look at your customer base and where the traffic is flowing. You can do a lot more with flows, but it definitely removes, as I've said, it removes the guesswork out of understanding where traffic is. And by the way, I got asked a question once about this, you know, is there other techniques for understanding how much traffic a particular peer uses on an exchange? And I said, yeah, turn the peering on. See where the graph goes, and then turn it back on again and see where the graph goes. If you want to run your network like that, feel free, but I truly don't recommend it. They call that destructive testing in the physical world, and I don't recommend it. Anyway, these are the key points. Graham, you're going to go on and talk about other stuff related to this. But thank you for the time. I hope that I sent some people off with a list of things to do and other people off with an idea that actually there's a lot more information in there. And thank you.
Okay, so
questions.
yes. affiliation so that people can hear.
Yeah, hi, Ben Roberts, with Telecom. Every time I go to look at my network data, my network engineers have turned it off if they say that it's affecting the performance of routers. Is this true or not? Can you expand on it?
I can neither confirm nor deny. So let's. It's actually a brilliant. I'll repeat the question because it's actually a brilliant question. Sorry, actually, management job title, product manager.
I'm a CTO.
You're the CTO. Oh, that changes this a little bit. Okay. Okay, let's just pretend you're in executive management, but not the CTO role. Okay. Your engineers are 100% right. Absolutely. They always are.
Thank you.
Because if this was easy, everybody would have done it and done it easily. There's actually one slide on this which I think sums up the pain and suffering of running flow software. Cisco originally came up with this concept. They called it version 1 of NetFlow. Anybody want to remember the date? 1989, 1990. It's a very early date, and it was bad, and it didn't work. And it would kill the CPU on whatever routers Cisco was shipping at the time, which, by the way, didn't have much CPU. You've got more on your iPhone and iPad than the Cisco routers that ran the internet back then. And version 2 never got released, and version 3 never got released, and version 4 never got released, and version 5 got released. And about in the mid-1990s, I know it was around in 97. And it still killed the routers, and it was painful to operate, and the collection software was a joke. But those that persevered got to see an insight, not to the quality we're seeing on data like this. They got to see an insight to how the network operated. And then version 6 came along, then version 7 came along, then Juniper came along, and then Brocade, Foundry Brocade, and then S-Flow came along, and then in fact actually various other things that came and went. And in all the usual sort of technical world, the world diverged. And only when Cisco came back with version 9, and then the IETF got involved, and basically version 10 became AfPIF3, did we get a standard that was well thought out, and that made, like all good standards, a lot of players come to the table and say, hey, this is worth doing. So, the problem is, it's painful to operate. It takes resources. It takes big boxes to collect. It takes money to be spent. Even in the open source world, it takes real money. It takes effort on the part of the engineers and the software developers. It takes effort on the part of how big a box, how good a disk drive you're running, etc., etc. But the reality is, it's one of those things worth persevering. Now, you're the CTO, so we get a different answer than what we do here. As a CTO, I would have thought you could both elect that this is a requirement in your network and then find the budget to do it. However, as a CTO...
They have the budget.
Yeah. No, that's not the point I'm going to get to. It's not whether you have the money. There's the will.
They have the budget. Yeah. The engineers have the budget.
Your best ally for this is on the product marketing side and on the executive side of the company. Because if you make these graphs human readable, if you make them understandable from want of a better way of being as crass as profit and loss point of view, because that's what they're showing. My traffic is going this way or that way. It is going to a transit or a peer. We're a peering model, so we're going to talk about that. It's going to go a long distance or a short distance before hitting a peering point. A customer is of type A or type B or type C, which may be high profitability or low profitability. All of these things play in. And your best ally for getting the resources and the money and the engineers to do flow data is to show the data to the rest of the world. I've seen people who have had flow data that only exists inside their engineers. They turn it on when they want it, they turn it on. They're missing the point.
They're missing the DOS or something like that.
Yeah, you get a DOS attack, you want to go look at it. So actually that's a very important point. I'm talking about flow data purely from the internet peering point of view. There are many, many other uses of flow data which I'm not touching, and looking for DDoS attacks is by far one of the more interesting things to do with flow data. Oh, and then mitigate, or being able to control mitigation comes out of that. I'm not touching that subject in this. So my answer to you simply is, find your allies, get the data out of the geek cupboard and make it available to the rest of the company and make it usable to the point when you can go get the resources. I mean, I'll tell you, in our environment, when our guys finally built a flow system that worked properly, and this took us many iterations, we ended up buying phenomenal amount of CPU and phenomenal amount of SSD drives and some pretty hairy database code that was written in-house. But the net result, pun intended, is absolutely brilliant.
Are you on about the collector?
I'm doing on the collector. Yeah, the route, we can talk about the router or the router side, and that's as much a conversation as the quality of flow data, the quality of its MPLS, the quality of its BGP, the cost of its ports. That's the capability of the router or the router side. That's a much bigger conversation. Yeah, get allies inside the company is useful.
Hi, my name is Sandton from Sandton. Thank you for the wonderful talk. So the fact that this information is split into flows, for the purposes that you've illustrated here, this sort of peering transit analysis, is the fact that it's split into flows is just really a useful way to have the routing not hold too much state. But flows actually tell us a lot of other interesting things, like who's making the connection, where's the content, where's the eyeballs. I don't want to give the providers here any funny ideas, but are you seeing this being useful for different kinds of models for billing, differentiated billing depending on who you're connecting to, or something even more crazy like how we have in the voice world a calling party pays model, something crazy like that?
So, it's actually, again, it's a great question. So the question is can you use this type of data on the customer-facing port to look at different billing models, using different ways of interpreting traffic? Well, the simple answer is yes, but don't go too far. Because keep in mind this is sample data. There's your first issue that to take into account. So from the simplistic point of view, the answer is yes. I showed you a graph that gave you a pretty good idea of what was transit versus what was peering. You could replace that in some way with something that's appropriate, in-country versus out-of-country traffic. You could make an assumption, because it's a sample, you could come up with a pretty good number. You could bill off of flow data, absolutely. But you can't go much further than that, because the further you go, the less data you have to sample, and therefore, the more variance that you will have. And when you have variance, the one thing you don't want variance in is a customer-facing invoice. Yeah. Because if you want to get the wrath of the other CFO, I don't agree with this bill, well, you better have a caveat again at the bottom of the bill saying it's approximate. And I don't think the word approximate should ever exist on an invoice. So, one of the things that I would turn around and point out is that you can take this to a certain extent. Now, you asked another question about sender party, not open power. Because, here's the problem. All you're doing, again, sampling-wise, is looking at flows that may have started before you sample, and may continue after you finish sample, and may have stopped and may have started. Statistically, we know that flows don't merge into each other because the numbers don't get reused. But who started the flow? You have no idea. You can make a good assumption, but again, the word assumption is sort of a hard one to throw on an invoice as well. So take this for what it is. The peering world, this is very useful for. For example, in the DDoS world, this is very useful. Flows are very useful, but only for big DDoS attacks. You get the tiny little ones, they go in the noise. They're very hard to find. So part of what you said, good idea. The other part, a step too far. question before anybody else asks the mic, or maybe nobody will. So out of this, the classic show of hands, we asked, Bill asked who was a peering coordinator, you asked who was a peering coordinator before, but you did, okay. So, who here is responsible for their company's, part of their company's profit and loss? That doesn't mean you start, it means that you actually, it's part of your job. Who has that responsibility where the, hey, I got more hands than you. Okay. The takeaway for you guys is very simple. There's expenditure on building networks, there's expenditure on infrastructure, there's expenditure on people. When you've understood all that, and then you want to go further, this is the tool that you want to use. This is the next step of looking into stuff. So, go find your CTO. You should be the right interface for stuff like this. Yeah. Go find your CTO and work out how to mandate information gathering like this and interpretation back to the rest of the company, because this is where the value is. In our company, everybody has access to this data within inside the company, and they use it for one method or another. Done with questions? Thank you. Oh, just in time.
Etika here from ES Canada. You've mentioned so many times the word sampling, and I want to understand what is a good sample, a sample that is good enough for one to say I can extract relevant data.
Yes, so you'll notice I ignored this subject in my slides. So the question is, what's the right level of sampling? Well, in the traffic graphs, the sampling is essentially one-to-one. If bits flow, you've measured them with tools like SNMP, and you've generated a graph. In flows, your percentage or your ratio becomes quite different. It isn't 1-to-1 or 1-to-2 or 1-to-10. It can be 1 to 5,000, 1 to 10,000. It can be 1 to 1,000 if you've got enough CPU. As your network grows, you're going to generate more flow data. As your network grows, you're going to generate more load on your routing platform or your switching platform to generate that flow data. So the reality is you may start adjusting your ratios. So it is not uncommon to see people start at 10,000 to 1. The downside of starting at such a high ratio, although it generates very low load on the router platform, on the collector platform. Oh, and by the way, any communication between the two, because remember, you've got to move the bits around your network, to your data center, to your place that you collect everything. But that ratio, if you don't have very much traffic, means you don't get very many samples. It turns out, if you notice a lot of the graphs I showed were in the 10 gig, 12 gig, 20 gig type range, 4 gig or whatever. So yeah, our network's pretty big. But the reality is that that level, although we have to adjust our samples, and it is very much a proprietary number as to how we run our numbers, as other people would have the same thing. But the reality is we have enough traffic that even at high sample rates, we get plenty of flow data. If you're only running a couple hundred kilobits or megabits worth of traffic, then you actually need to sample more often, because otherwise you just miss too much. There's just not enough there. The more customer traffic you have, the more peering traffic you have, the more bits are flowing, and therefore the sample rate can be adjusted. But you will see examples online in the 5,000, 10,000 to 1. Or on some platforms you'll see ratios that are powers of 2, 4,096, 8.92. That's just an implementation issue. But yeah, the numbers, the sample rates can be quite high. Which, by the way, brings back to the previous question as to why this is so hard to use for billing. Because that sample rate definitely softens out the graph quite dramatically, and is only useful for high bandwidth environments versus low bandwidth environments. Okay, thank you for that question. I'm going to turn off the mic. Thank you very much.
Thank you. Okay, good. That was a great presentation. Thanks again, Martin. So up next, we have Graham from Neology and also part of ISPAS South Africa. And his presentation is on how to build your network for peering. So, Graham, you ready? Full screen. Okay.
Okay, cool.